Welcome to Pindar Poetry. We hope you learned something new.
You begin by aligning requirements, performance envelopes, payload, and certification limits. Once that's clear, make sure to establish legal approvals and industrial partners. This determines who can supply engines, avionics, and materials. You'll also need a realistic budget and schedule, since aerospace programs run multi-year cycles. Avoid diving into fabrication details now. Focus first on governance, contracts, and systems architecture. Those choices shape the technical approach and downstream procurement. Next, concentrate on major subsystems and how they integrate. Think of the aircraft as modules, airframe, propulsion, controls, sensors, so you can develop and test interfaces independently. Once done, coordinate rigorous systems-level verification to validate performance and safety margins. Make sure suppliers meet the required specifications and certification standards. Component quality and traceability are crucial. Throughout, use simulation and modeling to reduce risk, and plan iterative integration milestones to expose issues early rather than at final assembly. For closure, focus on prototype validation, instrumented flight tests, structural proof loads, and avionics end-to-end checks. Once done, secure certifications and implement quality systems for production and lifecycle support. Make sure maintenance, spares, and training are defined for sustainment. If problems arise, rely on telemetry and structured failure analysis to isolate causes, then implement supplier corrective actions and repeat verification. This approach keeps schedules realistic and reduces risk, so you end with a safe, supportable aircraft design rather than unresolved issues.
Thanks for watching. Consider subscribing if we helped you.